So I want to talk about error handling kind of as a subject, all right? And so we're going to write a very simple little function here, def main, and we're going to prompt for two values. So miles equals input, please enter miles, and we're going to turn that into a float, and we're going to say hours equals float input, please enter hours. Sorry for those who are used to rational units, we're using miles instead of kilometers. Miles per hour equals miles divided by hours. Print miles per hour equals miles per hour. Okay, and of course, I don't know why that does that. I need to put an F there to use that kind of formatting. And we're done. If I could figure out how to. And then of course I need to call main. So that's a very simple little program. So we do, please enter miles. Let's say I went 20 miles in 2 hours and it's 10 miles per hour. Very good. Simple, easy, to the point. But what happens if I enter 10 miles in 0 hours? Well, now I get this really ugly mess, which obviously, because I'm a Python expert, or at least I've spent 8 weeks in this class now, I can figure out what this means. But for my users who are just trying to figure out miles per hour, this is not a very friendly response here. And so there are a couple of things we can do to dress this program up, all right? The first thing I should probably do is I should say if hours equals 0, print cannot calculate, I can't even spell MPH with hours equals 0. And so that would tell the user, if I had put a paren there instead of a curly, that will tell the user I don't like that input. And then I can say else miles per hour equals miles over hours, print miles per hour equals miles per hour. Okay, so now let's try that. Enter miles, 10, enter hours, 0, cannot calculate MPH with hours equals 0. That's a lot nicer than what we saw up here. However, let's suppose the user is really obnoxious and enters 10. Whoops! Now I've got this whole mess again about, cannot convert string to float, blah, blah, blah. That's not a very friendly response to my user. Well, all right. So what can I do to handle that? The way this code is structured, not a lot very easily. I could do, let's do miles string equals input, and then I could do if miles string dot is numeric, let's see, I need to do a not, right? If not miles string is numeric, print please enter a numeric value, else, but then I've got to indent everything here, and I still have the problem here if they don't enter a numeric value. Let's see. Well, let's try this and see how well we're doing. So miles equals float miles string, right? Let's at least see if that works, okay? So, whoops. Unmatched close paren. Well, complain, complain, complain. No, it's not that one. Which one is it? This one. Okay. All right, please enter miles. 10. Please enter numeric value. Oh, and then it kicked me out. Oh, well. All right, but at least that works. Miles per hour equals 5. Okay. But then, if I want to protect hours also from getting a non-numeric value, then I have to write more of this logic. And then there's even this problem here. Enter miles, 2.5. Please enter a numeric value. Well, 2.5 is a numeric value. Turns out that is numeric is not very understanding about what is a numeric input. So I'm getting in lots of trouble for where I just wanted to input two numbers and calculate miles per hour. And so one of the ways to simplify this is to come back to this. And this should be miles now. So it makes sense to check for 0 perhaps, but it gets messy, at least for my ideas here, to check for numeric inputs and floating point inputs. So instead we'll do something else. We'll use a try block. And a try block says we're going to execute everything in here, and we're going to allow for the possibility that some exceptional condition might happen. And for the moment we're going to go with exception, and we're going to say print unhandled exception. Okay? So let's try that and see what happens. Now if I say 2.5, 1, I get 2.5 miles per hour, and it didn't barf on the point of my 2.5. If I put in 10, it says unhandled exception. Okay, that's not real clear, but at least it's better than getting all that messy stuff like this. Now what I can do is I can figure out what type of exception that is. And to do that we need a variable. So exception as exception. And notice the case here. So I'm going to have a variable named exception which is of type exception. And this is going to say exception, and of course I need my F back here, but now this will tell me a little bit more about the exception. It says unhandled exception could not convert string to float 10. That's not a beautiful message, but well, it's better than all of this, and it's a little clearer than just unhandled exception. As it turns out, what I would like to find out is what kind of exception it is. And I don't remember if stir will tell me that. We'll find out. Unhandled exception could not convert string to float 10. So string for that is the same thing. Is there a type of? Let's see what that does. 10. Nope, type of is not defined. How about just type? If all else fails, of course, we can read the documentation, right? Unhandled exception, class value error. Okay, so what I could do is, and this is pretty useful because anything that I didn't expect to handle, this will tell me what kind of error it was. Now I can say except value error as error. It's really an exception, but for some reason they're calling it an error. Print value error like that. And now, of course, if I put my F in there, and somebody inputs 10, it says value error, could not convert string to float 10. Now, that's not 100% foolproof, except since the user has just entered 10 and I get that error, that gives me a pretty good idea of what's going on. And I say, okay, so I need to enter 10 there instead. And if I enter 3 for hours, it says value error, could not convert string to float 3. So I didn't have to write any additional code for hours. It got handled by these exceptions. So now if I say 10 and 3.3, we get miles per hour equals 3.03. Okay, that works out pretty well. So what have we got here? When I'm doing a division, I typically know that I don't want to divide by 0, and I want to give the user a very specific answer here. Obviously, I could have forgone this, and I could have put in, let's see, what happens if we just let it handle that as an exception as well. So now we're going to get 10, 0, 0 division error. So now I could put in a except, and I'm just going to cut and paste that because that's too long for me to type correctly. Well, maybe I'll cut and paste, and maybe I won't. 0 division error as error, print F. Actually, maybe we'll just print error and see what that does, okay? So let's try that. Put in 10, 0, float division by 0. Well, okay, that's not a great error. Great message, I should say. So we're going to say, actually, I'm just going to do that. Now you might ask why. Let's try that. Whoops. Well, it helps if I type everything correctly. 10, 0, 0 division error. You might ask, why don't I put please enter non-zero hours here? Well, if I spelled it right, it would make a lot more sense. In this particular case, that makes perfect sense. Please enter non-zero hours. The problem is that typically this is a lot more complicated code. It's calling other functions. I don't have any idea where that 0 division error came from. And so it's better just to say generically non-handled 0 division error, which is not what I had before, but something like that, that just admits something went wrong, I don't know what it was. And inside of my code, I should still have something like this. If hours equals 0, print please enter non-zero hours, else, and we do that. So this way I give a meaningful message. This is something that I started doing shortly before I retired, and I haven't been able to get rid of it. I don't let go of the shift key soon enough, and so I get 2 capital letters at the beginning of a word. Really irritates me. I didn't do that for all my career until shortly before I retired. And that's been, what, over 4 years ago, and I still can't fix it. Dang it. Okay, so where I know that I'm looking for a divide by 0 error, I put this message in to tell the user exactly what I want. If one of these slips through and I didn't handle it, then it'll get caught at the top level here. So for example, this might call calculate miles per hour. Maybe it says mph equals, and all this code is somewhere buried in, I guess typically we put that at the bottom. So def calculate miles per hour. Come on, reading. What'd you do? Okay. And so this will all hopefully handle zero division correctly. This doesn't handle input stuff correctly, and so I still have to have all this. But in fact, this is a good structure for a main program. I handle all these exceptions here so that I get a meaningful message out. And when I call my code, hopefully I handle the specific cases here so that I get a practical message telling the user what to do. And there might be several things in here. I don't know what else they might be. But so this is really kind of a safety belt for me. Handle things that I didn't expect to see. And this is defensive programming. Check for errors that I expect so I can give the user a meaningful message. So do you kind of see, I don't know how well I've, and incidentally, there's one more level here. There's except with nothing after it. Print really unhandled case. And I think I can trigger that by hitting Control C. Then it tells me really unhandled case. Because Control C is not based on exception. It's based on, I think it's called basic exception. I'm not sure. Print F unhandled basic exception. Let's see. Come on. Type. Oh, I forgot to put my as in there. As exception. And I think that will then handle the controls. Whoops. Oh, you know very well what I meant. These computers are so picky. It's like they expect me to do everything for them. Okay. If I hit a Control C now, it says basic exception is not defined. All right, that wasn't the right type. Maybe it's base exception. Like I say, if all else fails, we can always read the documentation. But it was base exception class keyboard interrupt. And so typically what happens is if I get this message, then I really want to figure out what went wrong. If I get either of these messages, I probably still want to figure out what went wrong and add a case up here. So you want to handle your most specific things up here, and your handlers get more general as you go down to the bottom. And this one is as general as you can get. That handles anything. And so, for example, this keyboard interrupt is not handled, is more general than exception. So I might put it down here, except keyboard interrupt as interrupt. Print F keyboard interrupt detected. And so now if I hit Control C, keyboard. Let's look at that. Is that spelled correctly? Keyboard interrupt. I think it's spelled correctly now. Keyboard interrupt detected. All right. However, I wouldn't normally do this because I like to keep these two at the very bottom. I consider them the most general, even though keyboard interrupt isn't based on exception. But you set up your handlers this way, most specific to least specific, and then this is really, I don't know what happened. In your code, when you have a logic error that you want to avoid, you write checks for that error. Another one is, what happens if I input negative hours? Well, the math will work just fine, right? Let's see. If I say miles, 20 miles, negative 4 hours, it gives me an arithmetic answer, but it's not very meaningful. And so I might want to say, if hours less than or equal to, please enter a positive number of hours. Okay? And so now, this no longer, the negative didn't cause an exception, but it did cause a meaningless output from my program. And so now I can handle that specifically with logic and give a meaningful response to the user. All right? And so that's another reason for doing logic checks as opposed to depending just on exceptions. Now you can also manually raise exceptions yourself. Well, let's see, let me back up one step. It would probably be meaningful in this case to wrap this in a try and indent everything appropriately, and then handle value error here. And now at this point I can say, please enter a numeric value. And that has more meaning than allowing it to be thrown up to the top level where it just says value error up here. Okay? Here I know that value error is probably caused by these calls right here, and I can give a slightly more meaningful error message than if it's trapped at the top level. All right? So now if I try it and I say 10, it says please enter a numeric value. Obviously, if I wanted to get more specific, I could wrap just this one in a try statement, and I would say please enter a numeric value for miles. Wrap just this one in a try statement and say please enter a numeric value for hours. It all depends on how much you want to do and how specific you want to get. But notice this is a reasonably well-written program. Maybe I've gone a little bit overboard in terms of pedagogical value, but how much of my code is involved in handling errors as well as this and this, and how much is actually my program? That line there, those two lines there, and those two lines there. Notice a lot more of the code is error handling than it is the program itself. That is not unusual. If you write good code, you're going to spend a lot of time checking for errors. Why? A, so your program doesn't just crash, and B, so you can give a meaningful message to the user so they know what they did wrong and can handle it better. Or if something goes wrong in the system, at least you have a slightly more meaningful message than your program crashed. So that took a while, but hopefully that gives you a little insight into error handling. Thanks.